Biorefinery System Module 11 Lignocellulose Biorefinery Engineering Segment 1 Transfer in Porous Media. With me, Yusuf from Bioengineering Study Program, School of Life Sciences and Technology, Institut Teknologi Bandung. Process engineering is a new discipline that has developed when basic theory and methods of chemical engineering processes are applied in the materials, metallurgy, biology, environment, and energy industries. Process engineering includes the study of process engineering principles, systemic measurement of data and information, as well as process integration, as shown in the right figure. Process engineering focuses on the study of physical, chemical, and biological conversion processes, aiming to solve the bottleneck in the transfer of laboratory results to industrial processes and create clean and efficient technology, processes, and equipments with the goal of solving the common problems of different areas in the process. This module will discuss the heat and mass transfer laws that apply in lignocellulose biorefinery process engineering, using porous media theory to explain the specific transfer laws for heat, water, and gas in the lignocellulose biorefinery process. That includes brief explanation on heat and mass transfer in porous media, theoretical basis of heat, moisture, and solid transfer in solid-state fermentation, as well as heat and mass transfer in the steam explosion process and its impact on the intensity factor. The porous medium, fluid and flow status determine the regulation of fluid flow through porous medium. The material system in the lignocellulose biorefinery process is a three-phase system containing of porous media, which can be seen as a typical porous media system, and thus could be analyzed by corresponding theory on porous media. Studies on the transfer process of lignocellulose biorefining can refer to the porous media process, which involves multidisciplinary theory of the flow porous medium theory, capillary theory, diffusion theory, fluid mechanics, heat and mass transfer, thermodynamics, and so on. Solid-state fermentation and steam explosion are two key units in the lignocellulose biorefinery process. This module focuses on solid-state fermentation and steam explosion, which are two representative units that can be used to explore the heat and mass transfer laws in the main lignocellulose biorefinery process. Analysis of the heat transfer process in porous media shows that the process includes heat conduction process of contact of a solid body with fluid in the gaps between particles, convective heat transfer of the fluid in the gap. It could be forced convection or natural convection or mixed convection of both, and also comprises the liquid boiling, evaporation, and condensation of steam, as well as the radiation of heat transfer between the solid body and the gases. A large number of experimental studies and results of theoretical analysis shows that for a particle that is not more than 4 to 6 mm in diameter, the contribution of convective heat transfer within the fluid is negligible, and the radiation heat transfer contribution is obvious only when there is a great temperature difference between solid particles and the pores are in a vacuum or are occupied by the gas. Thus, for a solid-state fermentation system, evaporative cooling and convection is more important method of heat exchange. The mass transfer process in porous media includes molecular diffusion and convective mass transfer. Molecular diffusion is caused by the random motion of the fluid molecules or solid microscopic particles. It corresponds to the heat conduction mechanism in the heat transfer process. Convective mass transfer is caused by the macroscopic motion of fluid and corresponds to convective heat transfer. Briefly, convective mass transfer includes both the mass transfer between the fluid and the solid body wall and the convective mass transfer between two immersible fluids. Single-phase fluid convective mass transfer is divided into laminar and turbulent flow according to different fluid states. The gas-liquid two-phases flow has more and different forms of convective mass transfer. The macroscopic motion of the fluid in the gap is caused by the capillary force, pressure, gravity, and so on. It should be pointed out that there is a mutual influence and a coupling effect among the transfer process of momentum, energy, and mass in porous media. For the next segment, we will discuss about heat, moisture, and solid transfer in solid-state fermentation. Until then, I am Yusuf from Institut Teknologi Bandung.